Hello everyone, myself Dr. Aditi Chatterjee. Today I'll be discussing the methods of block reduction rules in control system. So we already discussed transfer function. So that is basically Laplace transform of output by Laplace transform of input. If we have output as CS and input reference input as RS, then GS is the transfer function which is given by CS by GS. It is the means if we go into the definition, it is the ratio of Laplace transform of the output variable to the Laplace transform of the input variable, assuming all initial conditions to be zero. So now we will move to different rules of block reduction. Means if we have a series of blocks connected in a series and parallel, then how we reduce it to a single box. So first rule is if we have blocks connected in cascade. Means here we can see we have three blocks G1S, G2S and G3S. Those are connected in series, or if we can say connected in cascade. So if you reduce this block into a single block, then it will be like G1 into G2 into G3. Means if we have series of cascade of different number of blocks, if we have number of like n number of blocks in cascade connection, then the reduced form, if we represent it in a single box, then it will be multiplication of all the n number of blocks. So as here we have three blocks G1, G2, G3, the equivalent reduced block is multiplication of G1, G2 and G3. The input, reference input and output remaining same. Next we have blocks connected in parallel connection. So here we can see that we have reference input RS and output CS. And we have three blocks connected in parallel. Here we have a summer. So here we have the reduced block. Equivalent block will be G1 plus G2 plus G3. Note down, suppose if we have minus here, then suppose if we have here minus and G3 is also minus, then the reduced block is G1 minus G2 minus G3. So if we have n number of blocks connected in parallel, then the reduced equivalent block will be sum of all the individual n number of blocks. So here that's why the reduced block is G1 plus G2 plus G3, where RS is the reference input and CS is the reference output. Next, suppose if we have a summing point or adder, and we have input like XS, here we have YS and reference input is RS. So here we have two plus and one negative. So the YS signal is negative here. So the output CS will be RS plus YS, RS plus XS minus YS. So the summer will sum all the input, number of input. It could be 2, 3. So it will sum the number of inputs, the summer at the output. Now, suppose if we interchange the summing point, here you can see we have input in the first summer, we have input RS and XS. In the second summer, we have YS, resulting the output as RS plus XS minus YS. Now if we interchange these 2 points, then what we will have? We will have like basically we are doing RS minus YS means at the end we are getting the same thing. We are keeping it same. So you have to note down what are the signals, negative or positive, and accordingly you have to put the sign in the summer. Now, this is very important. If we shift a point from here, we can see the A is before the block GS. Now we are taking this after the block. This type of shifting or taking off a point from one point to another point will be required in your block reduction, and this is very important to understand also. Now see, here we have A. Now if you take this point after this block, means here we have A. Now here we are taking this block to this point. Now here, suppose the signal which is passing A and coming to B is getting multiplied to BS. Okay. Now if you take this point to this point, means that is here the signal is already GS. So if you take this point after this block, so this here we have to multiply 1 by GS, because here see the RS, in this RS, suppose there is unity gain in this part. Now if you take this point at B, what will happen? The signal at B is GS. Now our RS is unity signal. So the signal which is available at B is GS. But the signal RS should be unity. So to make it unity, we have to multiply it with 1 by GS. Now, here the signal is GS, that is getting multiplied to 1 by GS, resulting RS as unity. Okay, so here also you can see that if we take the signal from here, that is RS into GS. But we have here only RS. So what we have to do, we have to multiply it with a multiplier 1 by GS, so that we get here RS. Okay. So this is when we take off a point from A to B. We have the reverse also, means if we take the point from B to A, then what we have to do here at B, we have here GS. Here the signal is GS. Now if you take this point before the block, then you have to add gain GS to this part. So that's why if you take off a point from after a block to before a block, then you have to multiply, or you have to add the gain to this part at GS. So this is what we have to do if we take off a point from after a block to before a block. If we shift or take off point before summing point to after summing point, here we have RS. We are taking RS. Now, if you want to shift this point after the summing point, then what you have to do, you have to, here we have RS excess here. Now, here we have RS that is getting added with excess. So here we are getting RS into GS equals to plus minus XS. Obviously, this is our RS. And if the gain of the path is GS, then that is getting added to plus minus XS. Now, if you take off this point, if you take a point from B to A, means if you shift this point, then what we have to do, we have to add an additional adder in this part. Okay, so to make it same wise, if we take off a point from from after a summer point to before a summer point, then again what we have to do, we have to add additional adder in this part to make it same. Now, transfer, we already discussed this, but still, this is recap. Here, what is the transfer function of a closed loop system? If we have here GS, and the feedback could be positive or negative. Depending on that, if it is positive, we used to get negative, and for negative feedback, we used to get positive. So here, if the closed loop transfer function is given by keeping the input as Rs and output as Cs, we are getting Gs by 1 plus minus Gs. This is the transfer function of the closed loop system, which will be widely required and widely used for block reduction. Now, advantages of block reduction rules. It helps to construct easily block diagram of complex control system. We can be able to analyze the performance of each block individually. We can easily obtain the transfer function of the given control system. We can easily find out the stability of the control system through the type of feedback in the system. And also we can observe the functional operation of the block diagram through it. Now, disadvantages are for a complex control system, it takes a lot of time. During reduction of block diagram, some important function of the system may be eliminated. There is no information about how the system is constructed physically. It does not tell about the source of energy in the system. These are the advantages and disadvantages of block reduction method. Now, block reduction rule is very helpful method for determination of the transfer function of a complex system. It helps to simplify the complex control system into a simple control system so that we can analyze the stability and other performance of the system easily. So that's it for block reduction rules. Thank you. See you in the next lecture.